scholars today, alhamdulillah. We can well equip our knowledge. Yes, sister Huda, Huda, or what did you say? Hudaya, right? Huda
Yes,
or
Dr. Huda.
Dr. Huda, please.
So, in my opinion, although I do not know the regression very well, but I'll say that it also tells about the relationship between the variables. But the difference between correlation and regression is somehow we get the trend line or some equation in regression, some intercept or slope value, which we do not get through correlation analysis.
Okay.
I'm not sure I'm giving the right answer or not.
Yes. Yes. Any other?
Well, correlation can be seen through the Pearson correlation. According to my knowledge, regression are the impact,
Who is
effect,
this?
or the
Who is
causes.
this, sister?
Dr. Sadia.
Dr.
Dr.
Sadia.
Sadia.
Please, please.
These are the effects.
Can we see you, sister?
Actually, I'm somewhere out. I can't. Means
Okay.
it. I'm having some internet. Means internet
Okay.
connection issues. Na.
Okay. Okay. Okay.
Surely, sir. Next time, inshallah, we are going to have a video
Okay.
communication.
Inshallah.
So regression means causes and the effects of
Yeah.
independent variables towards the dependent variables. Simply, these are the effects that any independent variable can put on the dependent variables. Regression shows that. However, for the correlations, we are having Pearson correlation and other correlation test. Thank you so much, sir.
Yes.
Sir,
Please. Yes. 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 Please.
basically correlations gives us that either positive or negative, but regression correlate it in a quantifiable manner that effect of how much values of independent variable affect on how much value of dependent variable. Actually, it tells us that effect in a quantifiable manner.
Yeah. Mashallah. There,
So the
in the
extent
case
of
of
relationship,
yes, please, please.
we can get information from the regression that the extent of relationship, I think,
Okay. Okay. Very good.
positiveness or negativeness, the
Okay. Okay.
extent, and or either the other on the other hand, correlation just give us the information about the association
Okay.
between two variables.
Okay. Sister, yeah, brother Mukhtar. Yes, brother Mukhtar. You raised your hand to say something.
No, I think it's an icon he used on his profile.
Okay, okay, okay. So, actually, what happens in the case of regression, we want to observe the effect. Is there any effect of different independent variable over the dependent variable over the mediating variable? So, is there any effect when we actually, in our quantitative research, our study is mainly to observe the cause and effect relationship. Okay, since we are under positivism study, and positivism study, and we study based on the theory. We seek the theory first, and based on the theory, we take the different variables based on the recommended by the theory, and we take variables from the empirical evidence. Then after yeah, based on the theory and empirical evidence, we develop certain hypothesis, and based on that hypothesis, we take the instrument, and we collect data, and we observe is there any significant effect of these variables on that dependent variable. Actually, in our social science research, what happened, the our dependent variable is our problem, and that we want to solve. Our study to study the problem, and we diagnose the problem, and what are the different variables are causing that problem. So, what are the most important factors that are influencing that problem? So, that is why for resolving this we go to the exclusive literature for finding out what are the most important factors that are affecting our dependent variable or the problem. So, for observing statistically, is there any significant effect that we have developed as we proposed that these variables has a significant effect on this dependent variable? Statistically, we want to observe either is there any effect or not. Okay, and this effect can
Sir, excuse me, sir.
yes, please.
This is Janzeb.
Yeah.
Can we say, sir, in simple words, that percent change in independent variable can cause how much percent change in dependent variable?
Yeah. Yes,
Okay,
we can check it through the beta value, brother.
okay, okay.
Okay. So yes.
Excuse me. So I do think if two variables are highly correlated with each other, for example, A is highly correlated with B, in such case, A will better regress B variable. A will better regresses B. So regression depends upon the correlation between the two variables. And if two variables are correlated with each other, means if one variable is a regress is another variable, this is a simple linear regression, SLR, simple linear regression. And if there are more than one exogenous variable in a model and it is going to regress, means there are more than two variables in a model and which are going to regress any dependent variable, that is one, then it is a multiple linear regression, regression. I do think.
Yes. Yes, Dr. Mansoor, thank you very much for your good explanation. And nowadays, when we used to go to publish our paper in SSCI or impact factor journals, where we have seen our correlation table also need to give those, though we are planning to observe the regression, is there any effect, but the editor they asked for the regression table, is there any sorry, the correlation table, they want to observe is there any correlation among, if there is correlation then some regression might be there. So it is also necessary to observe the correlation as well for to observe the regression, the effect, to observe the effect or in structural, even structural equation modeling also, if you are doing your analysis by SEM, then also you have to put the correlation result there.
Sir, can we say like this correlations is the relations between the variables and regression is the intensity of that relations?
Exactly, sister. You are getting a correct answer.
Yeah.
Yes.
Mm.
Yes, sister.
Yeah. Thank you, brother.
Okay, brother. I think it's enough. Okay, let's share. So, how to do it? Linear regression models are used to show or predict the relationship between two variables or factors. The factor that is being predicted, the factor that the equation solves for, is called the dependent variable. The factors that are used to predict the value of the dependent variable are called the independent variables. The simplest form of regression analysis uses one dependent variables and one independent variable. That is the simple linear regression. And in the case of multiple linear regression, if we have more than one independent variable with the dependent variable. So, how to do this? Suppose OS has a significant effect on employee performance, welfare has a significant effect of employee performance, and fringe benefits has a significant effect on employee performance. So, for doing this we can do the analysis of regression analysis. So, how can we do this? Let us go to the last one. Please open the last one, regression analysis data. Please. Regression analysis data. Okay, this is the regression analysis data. I already computed the file given to you, already computed the mean value of all the variables. So, now what will we do? We will go to the analyze. Please go to analyze and go to the regression. Sorry. Then go to the linear. Okay. So, first of all we will observe the simple linear regression, then multiple linear regression. Simple linear regression means one dependent variable and one independent variable. Suppose fringe, one independent variable, and in statistics, estimates, confidence interval 95%, model, descriptive. Okay, continue, then save, standardized. Okay, then option 95%.
Sir.
Yes, yes.
Start from statistics, sir. Start from statistics.
Yes, I already did it. Oh, yes. Here what you have to select, you can go to the, you can follow this one. Suppose dependent variable, this one, independent variable, you can choose any one, wage, welfare or fringe or satisfaction. So, here in statistics, estimates, confidence interval 95%, model fit, and descriptives, you can select the descriptives as well, then continue, then you can get the result. Okay, descriptives, then continue. Okay, have you done? Then okay. Okay, now this is the result we get, that is fringe, either fringe has a significant effect on the performance or not. So, this is unstandardized coefficients or unstandardized beta, and this is standardized beta. What is the difference between unstandardized beta and standardized beta? Brother Shahriar. Sister Huda, are you there?
Yes, I'm here, but I don't know the difference between both.
Okay. Okay. Anybody can explain?
Sir,
Yeah.
Standardized beta is always used in the equation model.
Yes, yes, yes.
And even standardized coefficient shows the means to what extent the exogenous variable predicts the endogenous variable.
Yes, yes. Exogenous
That is
variables means independent variables.
means
Yeah.
yes, means 90% it predicts the endogenous variable performance.
Okay.
Okay.
Actually, here it is telling that 1 unit of changes in fringe, it will changes 0.19 0.19 unit of changes in the performance. Okay.
Yes, sir.
Okay, and the t value, we also consider the t value. If the t value is more than 1.96 in the case of two tail, then it is significant. In the case of one tail, I think 1.64. On the case, if the t value is 1.64 or more, then we consider it is significant. And this is the p
sorry,
value.
sir. Sorry, sir. This
Yes.
is
Yes, please.
Jihandev.
Yeah.
Sir, you mentioned under the heading of the beta that
Yeah.
1 unit
Of changes.
change in
Yeah.
will cause how much unit changes in dependent variable.
Yes, exactly.
Then, sir, what is the difference between percent change in independent variable can cause how much percent change in dependent variable, and unit change in independent variable can cause how much unit changes in dependent variable?
Yes, exactly, brother. Yes. And this is the significant value. Yeah.
Yes.
This is the significant value. It is like probability. If it is less than 0.05, then yeah, it is significant, right? And this is the lower bound and upper bound is the same. If it is not zero in between, that means both would be either positive or negative, then it is called. If the beta value, this beta value is negative, and if it is significant, then the lower bound and upper bound both will be negative. If the beta value is positive, that means if it is significant, the t value is more than 1.96 and significant p value is less than 0.05, then definitely it would be the positive. The lower bound and upper bound would be the positive. So this is how we explain. So brother Shahriar or anybody can explain what is the meaning of adjusted r square. We know the meaning of r square, right? What is the meaning of adjusted r square?
Yeah. I hope so. When we are having more than one exogenous variable, we do report adjusted r square. But in case of only one exogenous variable, we do report r square.
Is it okay?
Sir, may I supplement something?
Yes, please, why not?
Okay, thank you very much. As the discussion of the regression, we started talking about the causal relationship between the cause and effect of this thing. So the dependent variable is about our problem,
okay,
and we have to solve these things.
Who is this?
I'm Kamal.
Okay, who is Kamal?
Muhammad Kamal Hassan. Muhammad Kamal Hassan.
Okay,
Engineer
Kamal. I am just open your cam.
Yeah. Depending on the independent variables, we can find out the value of the dependent variable. So the adjusted R square is that how the independent variable or what extent, in what consistent values will be have the independent variables to solve or to find out or to figure out the dependent variable. If it is the higher percentage, I think that more than 50, 60, 65, then it would be highly correlated, highly consistent to give the correct value of the dependent variable on the basis of this independent variable. If it is the lower value, I mean adjusted R square's value is the lower, it means that there is no that much sufficient enough to reveal the dependent variable by the effect of the independent variables.
Okay.
Thank you, sir.
Okay, very good answer. Thank you very much, brother. Secondly, what is the meaning of adjusted? We know it is clear about R square value. What is the adjusted R square represent?
I will want to add something over here, if you allow me.
Yes, please.
Sir, the difference. Shahryar sir.
Oh, okay, please, brother.
The difference between R squared and I think so the adjusted R square value is that the R squared value assumes that all the independent variables considered affect the result of the model, whereas I think so that the adjusted R squared value consider only those independent variables which actually have an effect on the performance of the model.
For example?
For example, if all the variables in a data set have effect on the dependent variable, that for example we say that all the independent variables affect the result of the model or affect the on the dependent variable, we will just use the R squared. But if certain variables show drastic effect and if certain show not significant effect, then we will move toward the adjusted R squared. Maybe I am wrong, but I think so. At
Yes,
that point,
brother Kamal Hussein. Yes, brother.
I'm not sure. I guess if you allow me, like
Yes, please.
for collecting for there is some need, some noise like that. Thank you, sir.
Okay.
Like uh, if we just go for the collecting data, we collect lots of datas, or if we just think like observation of variables, so lots of raw variables and data we have, but those variables are not that much interrelated or that much effect on the dependent variable. Then we divide some operational variable or operational data that we actually use in the model that has the good correlation and good consistency with the dependent variable. So on the basis of those operational data sets, the independence variable is calculated with that R square is called, I think, that adjusted R square. Is it right, sir?
exactly, doctor, you are correct.
Yes,
I
brother.
also get the meaning from that.
Yeah.
Exactly, you are.
Yes, brother. I think it is clear now. Okay. Okay. So this is the R square is very important. The third here is only 0.03, 3% here. So simply, please mute your mic. Who is this?
Hello.
Who is this? Please mute your mic, brother. Who
Mute,
is
please.
this?
Mute, please. Sir, you.
Okay. Oh, who is this? Please check your mic, brother. Everyone, please. Okay. No. Okay. Now we shall check the multiple linear regression. Everybody, please go to the analyze and go to the regression. Go to the linear. Here, in the case of friends, we will add welfare, wage, and satisfaction all together. We can do, and then okay. See here, satisfaction with the performance, it is showing no significant relationship, as the p-value is more than more than 0.05. See here, the lower bound is negative and upper bound is positive. It is also confirming that. But welfare with the performance, if you check, t value is more than 1.96 and significant value is less than 0.05, and C lower bound and upper bound both are positive. So all of these fringe with performance, weight with performance, and welfare with performance, all are showing the significant relationship except the satisfaction with the performance. So here the R square value, it is showing the 10%. So according to higher, according to Cohen, according to Chin, they have different recommendation about the R square. So if we go to the according to higher, according to higher, it is if it is 75%, it is substantial. If it is 0.50, it is moderate, and if it is 25%, it is weak according to higher. According to Chin, it is 67% is substantial, 33 moderate, and 19% is weak. But according to Cohen, 35 and above is substantial, 15 to 34% is moderate, and 0.02 to 14 it is weak. However, in our case, we can where is the result? In our R square value is 0.10. According to Cohen, it is it is in between weak and moderate, so we can say it is weak. However, sometimes students of PhD they take the result in their shoulder. Oh, my R square is very less, what will happen? Actually, if your methodology is correct, if you do not have any problem in your methodology and question instrument development and in data collection, whatever result is coming, you have to truthfully you have to present your result. Whatever result is, you are suppose you are an objectivist and you are doing your study under positivism philosophy. So here the researcher just he is independent from the study. So what the result is coming, you have to present, you have to report that result. So sometimes supervisor do not agree and like this. Actually, we should not. We have to be very truthful about our result. What the result is coming, truthfully we have to. Our R square result is less. So what will be? So from this result is coming from your study. So whatever result is coming, you have to report it. That is your findings. That is your contribution. Okay. So this is all about the
Doctor,
yes, please.
sorry, excuse me. Doctor, I'm just wondering, because we are using a linear model, we need to fulfill the assumption of the linear model.
Okay.
But the normality we already fulfill. And how about the multicollinearity? We have not run the VIF value, and also we do not check the multicollinearity figure.
Multicollinearity, it is difficult to find out through the SPSS, but you can easily get it from the structural equation modeling.
Actually,
in the case of smart PLS, you can get inner VIF values, and in the case of AMOS, in the discriminant validity, you can get the value of R, small r.
Oh, Doctor, how about the Pearson correlation? We can see the R. So if let's say more than 90%, 0.9 is highly correlate.
Yes.
And also I think the VIF, also we have in
yes,
the...
it is similar like the VI, but I am not sure either this correlation will support if your correlation that is asking for the multicollinearity. I am not sure.
And then the variance inflation factor, I think.
Yeah.
we have in the SPSS also the variance inflation factor, but I do not know where that is from variance inflation
there
factor.
should be. I think there is some test for observing the multicollinearity. Maybe you will find some. But I never did it in SPSS. I always did in.
But normally previously, I think I've gone through someone do it the Pearson correlation to check the correlation.
We can do it from the collinearity test for
yes. Multicollinearity.
Yes, at that time we can find out the VIF.
0.9 and above is highly correlated. And also the variance inflation factor.
Less than 5.
Variance inflation factor is should be less than 5, but the some book they say less than 10.
Yeah.
VIF.
Yeah.
Okay, thank you, Doctor.
But here it all 3.3 is appropriate.
Yes, Brother Vishnu, can you open your cam, brother?
Yes. I can.
We want to introduce. Okay. How are you, Dada? How are you? Fine?
Fine, sir. Fine.
Okay, mashallah. You are from which state?
Kathmandu, Nepal.
Kathmandu. Oh, mashallah. Very nice.
Nice.
Okay.
If you come here, remember me.
Okay, of course.
We are taught in the social media as well as the WhatsApp contact.
Yes, inshallah. And everybody, actually, Nepal is a very nice place. There is a place in Pokhara, and Himalaya is there. So if you want to see the beauty of Himalaya, so please visit the Nepal. Very nice place.
Yeah, all are the most welcome.
Yes, inshallah.
In Nepal,
so,
in Kathmandu.
I would request everyone, please open your cam so that I can take some picture and some and we can know each other face. This is the platform. We are almost finished. Rahila Doshu, you're from?
I'm from Nigeria, Kaduna State.
Mashallah. Thank you, Fatima Baba. How are you, sister? Brother Samuel. Mashallah. Brother Samuel, yes.
Sir, I would like to thank you. Because I'm not software friendly. I'm not software friendly. So I learned something today. Thank you so much. I appreciate.
Okay. So yes, Brother Saiful Alam. Where are you from, Brother Saiful Alam?
Sir, I am from Bangladesh, Satkhira district.
Mashallah. Then Maheshwar Satpati. Where are you, Prof Maheshwar?
Hi, I'm originally from India. I'm from Bhubaneswar, Odisha.
Oh, Bhubaneswar, Odisha, mashallah.
Yes, it's very close to Bangladesh, by the way.
Yeah. Bangla, Bihar, Odisha, or Nawab was there. Sirajudullah.
Right.
We have a friend like Than from, I think from Myanmar, right? Brother Than, are you there?
Ayub Khan.
Than. Brother Than Hatiki.
Oh, yes, son.
Yes. Brother Peko, where are you from? Brother Peko, your mic is mute. Brother Peko. Okay. Where are you from, Brother Peko? Your mic is mute. Unmute your mic first.
Yes, doctor.
Yeah, where are you from?
From Cameroon.
Cameroon, okay.
Yeah.
Okay. Mashallah. Brother Imran Bahadur from Pakistan, right?
No. I'm from Mozambique.
Mozambique, but
Yes.
you look like us. India, like Indian from Indian subcontinent. Brother Adamu, how are you? Where are you from, brother?
Yeah, I'm from Nigeria.
Oh, mashallah, mashallah. Osaji. Osaji. Okay. Okay, mashallah.
Yeah. Yeah.
Sir,
Hello, doctor.
Yes.
sir, for your next class,
Yeah.
for SCM, so
Yeah.
I'll be texting you, sir, my details. WhatsApp, please.
Okay, okay.
The WhatsApp group and the details, sir. I'll be texting you.
Okay, inshallah. Brother
It's on
Daniel Doshu, please.
Yes, sir.
Yes, please. Where are you from?
I'm from North in Kaduna State, Nigeria.
North Carolina State, right?
Kaduna
Okay.
State, Nigeria.
Okay, brother. Nice to meet with you.
Thank you very much, doctor. We appreciate it.
Brother Alidu. Abdul Fattah, you were there in
From Ghana.
From Ghana. You were in Malaysia. We are friends, right?
Yes, UPM.
Yes, we meet there. Brother, why you did not talk with me before? Brother Abdul Fattah, you are
Yes.
a very good friend.
Yes.
We watched many times together, right?
Yes, please. Yes.
Thank you. And
In
you
South
joined many
City.
of my workshop, right? Many
Yes,
workshops.
yes.
Yeah, in my classroom session as well in UPM.
Yes.
In education department, I think.
Yes.
Brother Fazil.
Yes, sir.
You're from?
Afghanistan.
Oh, mashallah. Which place, brother?
Actually, I'm from the northern part of Afghanistan, which is Panjshir province.
Oh, Panshi. Okay, mashallah. May Allah give barakah in Afghanistan. May Allah give good iman. Alhamdulillah. Okay, jazakallah. Then, brother Santosh.
Yes, sir.
Please open your cam, brother Santosh.
Hello, sir.
Yes.
Sir, I am from West Bengal, India.
Oh, really?
Yes, sir.
ভালো আছেন দাদা?
হ্যাঁ স্যার, আমি ভালো আছি। আপনি কেমন আছেন?
জি ভালো আছি, আলহামদুলিল্লাহ।
আপনার ক্লাস সকাল থেকে করেছে, খুব ভালো লাগলো যে এত সুন্দর আপনি বোঝালেন সবকিছু। আমি আগে অনেক কিছু অ্যাটেন্ড করেছি, অনেক সেমিনার, বাট আপনার এই সেমিনারটা এত ভালো লাগলো। নেক্সট টাইম চেষ্টা করব সব সেমিনার আপনার অ্যাটেন্ড করার।
Okay, inshallah.
Very close to Satkhira, Bangladesh.
Yes. Okay, brother Bello Abdul Kabir. How are you, brother? Are you okay? Fine?
Hello, doctor.
Yeah.
Hello, doctor. This is Ismail from Nigeria.
MashaAllah, Israel from Nigeria.
From Nigeria, I really enjoy your class, doctor. May Allah reward you abundantly.
Actually, some brothers from India, Pakistan, and Nigeria, they made the workshop very live. Alhamdulillah, I am very grateful to them. Very grateful, especially brother Shahriar, sister Dr. Mansoor, and brother Kamal from Bangladesh, and sister Sadia, and Dr. Huda, Dr. Huda Javed. Maybe you have some issue in opening your ear. Inshallah. Okay, inshallah. So, if you have any question, then we can. I shall try to answer it, and some professionals are here. So, anybody have any practical issue? Yeah. So, I myself and other brothers will try to answer it.
Assalamu alaikum, sir.
Walaikum assalam.
His brother Abdulaziz Adeniji from Nigeria.
I need to leave now.
Thank you very much for the presentation. I really enjoy your class, sir.
Okay.
May Allah reward you abundantly.
Thank you so much, sir.
Okay. Brother Vishnu.
Sir,
Yes, sir.
Okay.
please permit me.
Okay. Okay, Brother Yadav, inshallah. See you, inshallah, my next workshop, inshallah.
Sir, Assalamu alaikum. Sir, sir, I have a question. Sir, how to calculate the odd ratio from regression model?
What, sister?
Sir, how to calculate the odd ratio from multivariate regression analysis?
What regression? I don't understand.
Odd ratio, sir, odd ratio.
Odd ratio. This is
Yes,
the first
sir.
time I am listening this word. Odd ratio.
Sister, I want to answer you.
Yes, please, Shahriar, brother. Please, you can address it.
We can obtain odd ratio when applying logistic regression.
Oh, yeah, logistic
You
regression.
can get the odd ratio value when you go for the logistic regression option. Then you will easily obtain odd ratio value.
Not in linear regression, right?
Exactly.
Yes, anybody have any other
Thank
question?
you so much.
Okay, see you inshallah, my next workshop, inshallah. Any other platform, we will see, inshallah. Okay.
Thank you, doctor.
Thank you very
Thank you
much
so
for your
much.
patience
Thank you so much.
to join.
Jazakallah, sir.
Thank you. Thank you so much.
Thank you, sir.
Thank you, doctor. See you next class, doctor.
Assalamualaikum. Bye-bye. Goodbye.
To all my brothers, I would like and sisters, I would like to say thank you for watching this, and it was a really amazing session. And inshallah, we will have these kind of sessions in the future as well. Thank you for
Inshallah. Thank
listening.
you very, Shahriar, brother, from my core of my heart.
Thank you, sir. Thank you.
Inshallah. Okay, see you, inshallah.